All right, greetings YouTube, Beautiful Mind here, and we're continuing our exploration on Chapter R of Functions, Graphs, and Models with Section R5, Nonlinear Functions and Models. A few objectives: graph nonlinear functions and solve applied problems, manipulate radical expressions and rational exponents, determine the domain of a rational function and graph certain rational functions, and then find the equilibrium point given a supply function and a demand function. So a quadratic function is given by f of x equals ax squared plus bx plus c, where a is not equal to 0. The graph of a quadratic function is given by this formula where a is not 0. This is called a parabola. Yeah, we're good. Some properties. It's always a cup-shaped curve or a U-shaped curve. It opens upward if our a is positive and opens downward if a is negative. Its turning point or vertex has a first coordinate given by x equals a negative b over 2a, so that's our vertex formula, the negative b over 2a. The vertical line x equals negative b over 2a is the line of symmetry, although it's not part of the graph, right? So once we identify our vertex and our axis or our line of symmetry, whenever we get a point on the left side, it automatically gives us a point on the right, and so we can use the axis of symmetry to quickly generate the parabola. So here we're asked to graph this quadratic and determine and label the vertex and the line of symmetry. If I were going to graph this, I would start with the vertex and then identify my axis of symmetry and then use the axis of symmetry to generate the graph. So we can at least do that. So the vertex, all right? So the x coordinate of the vertex, which is our h, that's going to be a negative b over 2a. So let's go ahead and calculate that. So our b in this case is a negative 2 over 2 times 1. Our a is a 1. So it looks like the final result here is a 1. So we're saying that the vertex, the x coordinate of the vertex of this quadratic occurs when x is 1. And then to find the k, which is the y value, that's just going to be f of h. So whatever answer we get, we plug it into the function. So that's going to be 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 minus 4. Okay. So the coordinates of the vertex, which should be our h comma k, looks like it's going to be a 1 comma negative 4. So that means our sometimes, so if you ever hear me say axis of symmetry, the book is referring to that as the line of symmetry. It's the same thing. Just, I'll call it line of symmetry right now. So our line of symmetry should be x equals 1. Okay. So we have our vertex, and then because our leading coefficient is positive, it should be a U-shaped curve that opens up. So for instance, when x is a 1, we have our vertex at 1, negative 4. We can quickly see that when x is 0, the corresponding y is a negative 3. So that means that when x is 2, the corresponding y is also a negative 3, right? And we can use that to generate our parabola and then connect the points with a smooth curve. And so here we have a type version of that. So the first they identify the a, b, and c. We see that a is positive. The x coordinate of the vertex is negative b over 2a, which is 1. We got the same result. To find the second coordinate, we take that and plug it into our function. We get a result of negative 4. So that means our vertex is going to be 1 comma negative 4. And the line x equals 1 is going to be our line of symmetry. Then we can use that line to generate points on either side. Whenever we get a point on the left, we automatically get a point on the right. And we can use that to plot our points and connect them with a smooth curve. You see it here. Okay. Quick check I'll leave as an exercise for you. My recommendation, try to answer the questions, without using the support there, The more you can answer the questions with the least amount of help, the better off you'll be. So then the solution of any quadratic equation, ax squared plus bx plus c equal to 0, or a is not 0, are given by, basically this is the quadratic formula. So I kind of want to share this. The way one of my students remembers this formula, he does the following. Let me see. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks and it was all over by 2 a.m. Right? So it's just a little, that's called like a memory palace technique, where if you're trying to remember something, you associate it with something that's zany. The more zany it is, the easier it is to remember. And so, yeah, it's like a mini movie. That's how I remember this one, but we have it here. Okay, so if we wanted to solve this, we can use a quadratic formula. Sorry. Again, negative b plus or minus the square root of b squared minus 4ac all over 2a. So our a is 3, our b is negative 4, and our c is negative 2. We plug it in and calculate. I'm just going to use my prepared notes. Okay, and we get this result. 2 plus or minus the square root of 10 over 3. Okay. Quick check, I'll leave as an exercise for you. So the definition of a polynomial function. A polynomial function f is given by this, where n is a non-negative integer and our coefficients are real numbers. Again, these are called coefficients. So n is a non-negative integer. So our n's are, well, n is like, it could be 0, it could be 1, 2, 3, right? Non-negative integer. If it was strictly positive, then it couldn't be 0. It had to be greater than 0. So using the same set of axes, graph x squared and x cubed. So for this guy, we're going to make a table of values. So choose several values of x, find the corresponding y, and plot them on the same coordinate plane. We can do something like let x be probably like either negative 3 or negative 4, right? So like negative 3, negative 2, negative 1, 0, 1, 2, 3, maybe 4. Probably just 3, because I think 4 gets too big too fast. So we choose those x values, find the corresponding y for each of these, and plot them on the same graph. I'm going to use my prepared notes for this instance. You see it here. So they did negative 2, negative 1. They used a half. And then if you plot them on the same plane, we get an image like this. So the definition of a rational function, functions that can be written that can be given by the quotient or ratio of two polynomials are called rational functions. So rational functions are basically like fractions. One main thing whenever we're working with fractions, you have to be cognizant that we cannot divide by 0, right? We don't want to divide by 0. So this is called the reciprocal function. You could plot points, right? So choose several values of x, find the corresponding y. So things like, you want numbers that approach 0. This is basically centered around 0. So like, you can let x be something like negative 10, negative 5, negative 1, negative 0.5, negative 0.1, a few points like that. Then you want to get onto the right side of 0. So like 0.1, 0.5, 1, 5, 10, stuff like that. Okay. So we would choose several values of x, all right? And long story short, we get an image like this. So you can see on the left where they chose several values of x, they found the corresponding y's, plot the points, we get an image like this. Okay, so now we want to explore y is inversely proportional to x if there is some positive number k for which y equals k divided by x. So before we had what? Something was proportional, like y was proportional to x. So that showed up as y equals, I think we expressed it as k times x. I think the book may have used like m times x or something. Same deal. But for inversely proportional, now we say y equals k divided by x. So Women's National Basketball Association, WNBA team, notices that as the average ticket prices increases, the number of tickets sold decreases, and as the average ticket price decreases, the number of tickets sold increases. Suppose that 10,000 tickets are sold when the average ticket price is $40. Assuming that the relationship between the ticket price X in dollars and the number of tickets sold Y is inversely proportional, find the number of tickets sold when the average price is 50. Okay, so if they're inverse, let's take some notes here real quick. If they're inversely proportional, then it should be the case that what? Y equals k over x, okay? Now they gave us some information. So when 10,000 tickets are sold, the price is 40. Let's see, average ticket price. Okay. So if we plug that information in, 10,000 tickets should be equal to some K over $40. So then K would equal 5. Let's see. 1, 2, 3, 4, 5. 400. Okay. So then our claim is that, let's see, ticket price in dollars and the number of tickets sold. So then the number of tickets sold is going to be 400,000 divided by X. So whatever the price is, we say 400,000 divided by that price, and that should give us a sense of how many tickets we're going to sell. So find the number of tickets sold when the average price is 50. So then we let X be 50. Let me see if I got this ready. So if we say 400, 1, 2, 3 divided by 50, so we can anticipate 8,000 tickets. I'm just going to write the result here. Tickets sold. Come on. Okay, let's see how do we do. Assuming that y equals k over x, we substitute 10,000 for y and 40 for x, so we get k is 400,000. So then, if we sell it for $50, we can anticipate 8,000 tickets. So when the average ticket price is $50, about 8,000 tickets will be sold, okay? Graph f of x equals absolute value of x. So this definition is what? Is x whenever x is positive, and is negative x whenever x is negative. So you would do this like a piecewise function. But basically it's a V where the vertex is at the origin, and the slope of each diagonal line has a slope of like 1 and -1 respectively. You see it here. Again, you could choose several values of x, find the corresponding y, plot the points. In this case, you would connect it in the appropriate fashion using straight edges. Okay. So then square root of x. So for instance, the domain of square root, we can't take the square root of negative numbers. So the domain here, x has to be greater than or equal to 0. So you could choose values of x, but you have to start at like 0 and then like 1 to, probably some perfect power. So like 0, 1, 4, 9, those values of x, find the corresponding y, so on. Plot the points, connect them with the curve, smooth curve. So power functions with rational exponents. For any non-zero real number a and any integer n and m, a to the power of n times a to the power of m, we basically add the powers. A to the n divided by a to the m, we subtract the powers. A power raised to another power, like baby's kids, we don't die, we multiply. And then a raised to a negative power means 1 over that power function. Rewrite each of the following as an equivalent expression with a rational exponent. So the fourth root of x, again, whenever we have an even root, we can't take the even root of a negative number. So that's why they tacked on that x has to be greater than or equal to 0. As a rational exponent, let's do this color. Actually, let's do this color. As a rational exponent, this is going to be x to the power of 1 over 4. This one should be r to the power of 2/3. This one should be square root. So 10 divided by 2 is x to the power of 5. I got to think about that. It might be an absolute value in there. I think it does have to be positive. Yeah, I'm a little stuck right there. They might include an absolute value. I'm just going to go with it. Okay, so then this guy should be b to the power of a negative 5 over 3. Okay, let's see how do we do. 1 over 4, 2/3. Okay, so they did not use the absolute value. B equals a negative 5/3. Okay, I think we're good. Suppose the relationship between the price P of a 1 pound box of sugar and the quantity Q of boxes that consumers will demand at a price is given by the table in the graph. Quantity versus the price. So our demand function, okay. Okay. Suppose the relationship between the price of sugar and the quantity are willing to buy or sell is given by the table. So the previous was a demand schedule. The next was a supply. Okay. So the equilibrium point is going to be the price and quantity for which suppliers are willing to supply and consumers are willing to buy. So supply and demand, okay. It's the intersection of these two functions. So that's the equilibrium point, okay. So find the equilibrium point for the demand and supply functions of this ultrafine coffee maker. Here Q represents the number of coffee makers produced in tens of thousands, and P is the price of a coffee maker in dollars. Okay. So we have our demand function, our supply function. So then the equilibrium point, if we set these guys equal to each other and solve, okay, let's see. So then we have this 200 minus 4Q equals Q plus 25. Let me write legibly, because if I'm going to forget that that's a 2, then I'm going to come back and be like, why am I getting this wrong? Because I couldn't read my own handwriting. Add the 4Q to both sides and subtract the 25. Eventually you'll get 5Q equals 175. I'll keep working over here. So then Q equals, what is that, a 35? So the price, coffee maker, $35. That should be how we maximize our profit, where the demand function equals the supply function. Okay, let's see, how do we do? To find the equilibrium point, the quantity demanded must match the quantity produced, 35. So therefore, the equilibrium point is 3,500 units. I thought that was the price. Q. Oh, yeah, we did solve for Q. Okay. I totally read that wrong. Okay. In thousands of units. And the units are tens of thousands. Okay, so I got to backtrack a little bit. That totally is Q, and I didn't read it right. Tens of thousands. So let me see. 1, 2. I think it's like 4 zeros. 1, 2, 3, 4 units. And then the price, we just take this and plug it. Why is that not behaving? What am I missing? 350, yeah, units. Oh, okay, $60, okay. So you plug 35 into the, like the supply, right? Into either one. You just got to keep it, just use the 35, right? Because I was tempted to use 350. I was like, that's not right. But yeah, we plug in the 35, $50, $60. Okay, yeah, that's fine. That's fine. Yeah, and then like, cause I was getting some ridiculous number. I was like, that doesn't make sense. You're not gonna sell a coffee maker for 350,000, 60. I was like, that's. Sorry, my units were just off, but yeah, we got to the bottom of it. It's fine. So the equilibrium price is $60, and equilibrium point here, where Q of E is in tens of thousands of units. That's fine. So the units got a little bit squirrely there, but we're okay. All right, and so with that, we're going to go ahead and end the session here. Now, from one beautiful mind to another, take care and peace.